All right, let's start. And hey guys, I'm Jac. I work at Kentik, and I am going to talk about peering with you. We're going to wake up a little bit because I want to know something from you. What tools are you guys using in your role as a peering coordinator, or what tools are you using to look at the traffic that you have that determines whom and where to connect with? Anyone? Come on, there must be someone. Nobody uses a tool? I don't believe it. Excel. Anybody? No hands? Does anybody do any peering here? Corrado. That's a tool. Trace routes. Anyone? Peering DB. That's a good one. Wow. Are you still asleep? You're looking for beer, right? You're waiting for the beers. Yeah? Okay. So yeah, there's a lot of tools out there. There's a lot of sources that a lot of the network operators like you use to find out whom to pair with, where to pair with, how to optimize connectivity to the rest of the network, of the rest of the internet. How do you save money by connecting to other networks? How much money do you save? No? All right. So there's a lot of tools out there. Statistics on your traffic, peering DB, spreadsheets, trace routes, all tools to find out what is actually happening in my network, where is traffic going to, where's traffic coming from, how does it get there, what internet exchanges are involved? Is Netnod involved, yes or no? Any other internet exchange? It will give you a good insight on what's happening, but you can add more sources, like NetFlow data. Gives you information about IP addresses, protocols, port numbers, destination and source networks. A lot more data to be used to determine where to set up your peering or with whom to pair. Does it give you enough information? Well, it gives a lot of information. It gives you like, what traffic do I have? Where is it from? What traffic is it? Who's my transit upstream? Any of that information is important for you to actually determine what's happening in my network. But does it give you enough? Don't think so. You want a lot of the enrichments in there, so you want more sources. You want to know, in what region of my network am I exchanging this traffic with others? What is the cost? So you possibly have transit upstream networks, tier 1 service providers, we'll give it a name. How much money do they cost you? And are you using that connection to the max? Are you using committed rate or are you using burst rates? All kinds of information that you need to make the actual decisions. So we want to add a lot of information there. OTT services, caches. Do you have embedded caches? Yes or no? Do you connect directly to the CDNs? Yes or no? Where the OTT traffic comes from. All kinds of sources that you need to make a good decision. So how do you do that? There is no single source of truth. You know, for determining who and where to pair with, there is no single source of truth. There's a lot of data out there, spread out across numerous sources. We can all build all kinds of automation systems. I think we've heard presentation about automation system, deploying config to devices. We can automate the hell out of the network, of course. We can do this with this as well. Pull in all those data sources, use the API, push it into a platform, and that can enrich all the data that you have, and there's your entire data set. So what does that look like? So we have all the sources on the left-hand side. That all goes to a big ingest engine, gets stored, you're able to query it. There's also some alerting there and automation capabilities using the API, detecting anomalies. Hey, we can detect DDoSes now because we see traffic in NetFlow data. We see anomalies in the traffic. Or maybe we see a traffic shift from one network to the other network. What happened there? So we now have all the telemetry from the network in a single source, and we can start querying the data and really find out how do we connect and where do we connect with. Helpful so far? Anybody thought of another tool they use? Wow, you're quiet, guys. So, what are the results? We now have all that data in that single data store, all the enrichment in there. So we can start asking ourselves questions like, do we use our connected port to the Internet Exchange good enough? Or is there potential? Let's have a look. So this example talks about an Internet Exchange in Amsterdam, not far away from where I live. You probably heard that about my accent, but I can't hear that from you, by the way, because you're not talking anyway. So. So what are we querying here? So we are asking a certain platform about traffic. Show us the total traffic that is traffic that has a network boundary. One of the enrichments that you can do to say, well, I just want to look at traffic that is outside of our network, coming into our network. So we'll look at external traffic coming in. It has to be traffic that comes in over transit, and because we're investigating how much traffic we will have on this certain exchange, we also use an integration from PeeringDB where we say this network has to be connected to this internet exchange. So we set that up in a filter. Put some more in there about peering policies, but you guys don't do any peering because you don't have any tools. But peering policies are open or are closed, are selective. You know all about this, I think. So we query that as well, and there's the list. There's your total traffic. Wow, we can do 15 gigs with the traffic that we have in our network if we would connect to M6. Cool. But now you want to know where's the traffic over coming into our network nowadays then? We'll just change the query and we're still utilizing all those sources of information. We change the query and say, we don't want to see the total traffic. I'm not tall enough, although I'm Dutch, but all the way up, we can see we added a dimension that says source provider. So now we know what are the source providers that carry that traffic into our network. Cool, or? Yeah? Wow. There's people talking. That is a good question, and that is our demo system. There's people playing around there, making typos and stuff like that. I should have cleaned it up. I also like this provider. That's my favorite. But yeah, so now we can actually see who's the source provider and how much traffic do we have coming in from those providers that we could actually carry over the M6 connection as well. Great stuff. How much does that cost? Adding a lot of data into a single source allows you to look at cost as well. So now we can see for those providers we just saw in that graph, how much traffic, how much money do we pay them for the traffic. And when you add all the information, all the context here, we can even tell you about, well, hey, you have a committed rate here, so you put more traffic on it, so your price per megabit goes down. Or you're only bursting here, so you have a small contract with them, and you only pay for your burst traffic, which often is quite expensive. So you don't want to burst there, so you don't want to carry traffic over the network, so probably have to move that away to somebody else. So that cost per megabit here, this table is an important one. If you're want to optimize your network on cost. You look at that price, you look at the traffic. Is that traffic that we should move? Is that traffic that we should, increase to make it cheaper? So a lot of data that you can that helps in trying to find out what peer you should connect and what traffic you should take away from that transit provider. We're still looking at, are we using that internet exchange well? Are we doing good there, or could we still optimize that? So we looked at the providers. We now changed, if you look all the way up, the dimension from that source provider, we changed that to the source network. So now we actually know who are the networks that are sending that traffic. Not what's my transit provider, but what's the network behind that transit provider or in front of the network provider, just depending on the view you have on it, but I always say behind the transit provider. So now we see what networks are there sending you all that traffic over that transit provider that we saw in the previous slides that you pay for. So you probably want to move this away from those transit providers. So now we have used a lot of data sources in that one integrated solution that tells you, well, hey, here are your peers, you should go and talk to them. And since we have all the integrations, you can directly go to the PeeringDB record, look at the contact details, find out where they are situated, what facilities or what internet exchanges, find the nearest and stuff like that. So that makes it really easy to find new peers, potential peers, offload traffic from your transit, save some money as well. Another use case. Say you're building out your network and you have plans to build in a certain location. Maybe there's multiple exchanges there, as we often see. Which is the best to join with the traffic you have in your network? So here we go. A new query, again, using PeeringDB. And we're doing something funny up there with the dimensions. So we saw that we can build filters. We can use the filters to create dimensions as well. So now we say, well, use filters that say something about the internet exchanges in that city that you're trying to build. So that's what we created here. So we're now looking at traffic split out over the different exchanges to basically determine what is the best exchange to connect to. So we have all the traffic coming into our network. In that, did we set a filter on the region? No, we did not. But we do set a filter based on the internet exchanges that are there. We'll see that in the next slide. So now we see the traffic in your network. How would that be distributed over the different exchanges if you would connect to those? So that's the breakdown. And how do we do that? Well, that dimension up there is basically a filter where we say, create a dimension links nova, which basically is a filter that says, show me all the networks that are connected to links nova. So if you push traffic through that filter, you will see how many traffic in your network could be carried over that connection to links nova. So if we go back, we did the same thing for Equinix and Ashburn and the same thing for Digital Realty. So now you can see by using these types of filters, breaking it down, we can actually see how much traffic you would have if you would connect to these internet exchanges. So this helps you deciding in, okay, so based on this traffic, the internet exchange that would carry most of it would be Equinix and Ashburn in this example. Useful to you guys? I see people sticking the thumbs up. It's no noise, but it's a signal. That's okay as well. More signals. Yeah, cool. Kind of similar question. It's not about what exchange should we connect to, but where should we, geographically, where should we build? Again, new filters, using the enrichments that we can do, destination, region, and city. So we see a breakdown about the region and the city. Again, filtered on traffic that comes in from external. That traffic is transit traffic, and the destination networks have an open peering policy. So they are willing to pair with us. So this is the traffic, but then broken down on the region and city. So we have Ohio, Columbus, really American slide, by the way. I should change this to European, which is much better to understand, so I know where things are. But anyway, so if we zoom in on Ohio, for instance, because we see Ohio, Columbus has the highest amount of traffic. Was that a finger going up? Nope. So Ohio has the largest amount of traffic, so that basically is a potential place to go to and build your network out to, because you're handing off a lot of traffic there. So which data centers are there? Again, use a dimension that's based on filters. We can see what data centers are there, and important to make a decision, how much traffic do we have on those data centers? Really easy to find out. So connecting in Ohio, building out to Ohio, connecting in the data center, which is called call 1. Again, using those filter dimensions. So, a big shout out to anyone that uses a lot of data sources, but especially the PeeringDB, because a lot of these examples use the integration that we have with PeeringDB. So I know there's another presentation following here about PeeringDB, but please use that database, guys. Update everything in there, support them, keep your records updated, and bring in ideas to improve this, because it really helps you all in finding out how to build and optimize your network. And like we always say, enriched data is a way to create efficient workflows. We can use this data for so many use cases. I just highlighted 3 of them, but there's so many things that you can think of that you can use all this, all these data sources for, where you can optimize your way of working, where you can optimize on cost, on the quality of your connection. So use all those data sources. Thank you, guys.